If x plus 2 and x minus 5 are factors of the function f of x equals x to the fourth minus 5x cubed minus 7x squared plus 29x plus 30, what are the other two factors? Well, this particular function, f of x, happens to be a fourth-order polynomial because its highest degree here is 4. And we're being told that there are two factors that we know, namely x plus 2 and x minus 5. Those are factors of this polynomial. So what we're going to use is synthetic division to first of all divide that polynomial by x plus 2, and then use synthetic again to divide that by x minus 5, and then hopefully at that point we can factor to find the other two factors. So the way synthetic division is going to be used here, you start by writing down the factors, or I'm sorry, the coefficients 1, negative 5, negative 7, 29, and 30, and here they are. 1, negative 5, negative 7, 29, and 30. Now the next thing we do, associated with this x plus 2, is a 0 of negative 2. So we put the negative 2 over here. And at this point, we start by dropping down the 1, and after that it's just multiply and add. So we multiply 1 times negative 2, we get a negative 2. When we add negative 5 and negative 2, we get a negative 7. And then negative 7 times negative 2 is positive 14. When those two get added, you get 7. 7 times negative 2 is a negative 14. And 29 minus 14 is 15. And finally, 15 times negative 2 is negative 30. And we get a 0 remainder. It is not surprising that we got a 0 remainder because we were told that x plus 2 is a factor of this polynomial. So effectively, what we've done at this point is we have rewritten this polynomial up top there as x plus 2, which is one of the factors, multiplied by, and then I reel off these coefficients right here in a cubic polynomial. So this will be x to the third power minus 7x squared plus 7x plus 15. Now, at this point, we would like to take this polynomial, it's a third-order polynomial, and do synthetic division with this other factor. So let's write down the coefficients that we have here. We have a 1, negative 7, 7, and 15. I'm going to do synthetic division. But this time, instead of working on this first factor, which is x plus 2, we're going to divide by x minus 5. And the way you do that is you put a 5 over here. Same story for synthetic division. Drop the 1 down. There's the 1. After that, it's multiply and add. 1 times 5 is 5. When you add negative 7 and positive 5, you get a negative 2. Negative 2 times 5 is negative 10. When you add 7 and negative 10, you get a negative 3. Negative 3 times 5 is negative 15. You add 15 and negative 15, and you get a 0. We're not surprised that we got a 0, just like we got a 0 here, because we were told that x plus 2 and x minus 5 are factors. But look what just happened. We took this third-order polynomial, divided it by x minus 5, and this is what's left over. So as an update here, now what we have, put a line here to separate these out, we have x plus 2, and then we're going to replace this third-order polynomial by x minus 5, multiplied by the quotient. And the way you get the quotient is you look at these coefficients down here. This will be x squared minus 2x minus 3. Next step. Here is our x plus 2, the first factor, which was a known factor. Here is x minus 5, our second factor. And we're going to see if this remaining quadratic here can be factored. So the way you do that is there will be an x here, and there will be an x here. We have a negative 3 out here, so we want to put a 1 here and a 3 here in order to achieve a negative 2 right there. This should be plus 1 and a minus 3. So if you go back to the original question, which asked for the remaining two factors, those other two factors, in addition to the 2 that were given, are x plus 1 and x minus 3.